In this video, we're going to look at cations and see that most of the time cations are acidic unless they come from a strong base. So let's go ahead and start this explanation off. So imagine you've got a cation from a weak base. And we write the KB reaction, so we know that bases react with water. And I should probably put some state symbols in here maybe. And what do? They abstract, they take a proton from water, and they convert into the conjugate acid form, and they release the hydroxide ion, which of course is what raises the pH, and that's why we call it a basic solution. If this is the base, then this is the conjugate acid. So here's my base, and here's my conjugate acid. And so the conjugate acid here you can see is a cation. It's positively charged. So anytime you're forming a cation that's coming originally from a weak base, you know it's behaving like an acid. So what are some classic examples of weak bases? So some classic example of weak bases are things like ammonia. And ammonia, of course, can accept a proton and form the ammonium ion. And we're going to see that that is going to be an acidic cation. We can look at things like methylamine. Methylamine is another classic weak base, and of course it can accept a proton and form this CH3NH3 positive cation. And again, because it comes from a weak base, that the cation there must be acidic. Now, instead of weak bases, if you look at strong bases, so strong bases are things that undergo complete dissociation. So something like sodium hydroxide breaks apart and forms sodium and the hydroxide ion, something like strontium hydroxide. So remember, those group 1 and 2 hydroxides are often strong, so it breaks that and forms strontium and 2 hydroxide ions. So we've already seen that this would be the base, and this would be the conjugate acid. Okay, so these are the conjugate acid-base pairs. However, because these bases are strong, they don't undergo the reverse reaction. So the reverse reaction does not happen, which means that these actually can't act like bases. These can't act like acids, right? They can't react with that OH minus and go backwards. And so rather than calling them acids here, I'm just going to cross this out and say that they are completely neutral. So whenever you've got a cation that comes from a strong base, it's going to be completely neutral. So what are our strong bases again? So things like sodium hydroxide, lithium hydroxide, potassium hydroxide, and in group 2, things like strontium hydroxide, magnesium hydroxide, and calcium hydroxide. Okay, some of these aren't very soluble, but if they are soluble, they definitely act as strong bases. So if those are strong bases, then they're all going to have those 6 neutral ions. So the sodium ion, the lithium, the potassium ion, they're all going to be neutral. The strontium, magnesium, all these are dipositive, so the calcium ion, these are all going to be neutral. So whenever you see one of these cations, right, you know that it's not going to react with water, and it's not going to change the pH at all. So that's a lot to remember. So let's try and go ahead and give a quick summary. So I'm going to write cations on the left, and I'm going to write anions on the right. And so we saw that anions are often going to be basic. And the classic example of a basic anion is the hydroxide ion. So that's the easy one to remember, right? So these guys are going to be basic. On the other side, cations are going to be acidic. And the way to remember that is the hydronium ion is the classic ion that lowers the pH and makes a solution more acidic. So I think that's an easy way to remember whether you've got an acidic or a basic ion. Now, if your cation comes from a strong base, it is going to be neutral. Okay, now there's not too many strong bases. So you've got lithium hydroxide, you've got sodium hydroxide, you've got potassium hydroxide, you've got strontium, magnesium, and calcium hydroxide. So if it's any one of these, it's going to be neutral. Otherwise, it's going to be acidic. So any other cation you like, so like iron 2, or aluminum, or vanadium, or whatever your favorite cation may be, it's going to be acidic otherwise. And on the anion side, right, so if they come from a strong acid, a strong monoprotic acid, so something like hydrochloric acid has the chloride ion that's neutral, and hydrobromic acid, or hydroiodic acid, or nitric acid, or perchloric acid. So all of these are from strong acids, and they are going to be completely neutral. And the reason for that is that the strong acid, once it breaks down, it never reforms. So these ions can't act like bases and reform. But otherwise, all your other anions are probably going to be basic. So we've already remembered, right, the hydroxide ion is the classic archetypal basic ion. But everything else on that list, so like fluoride ion, right, it comes from hydrofluoric acid, which is weak. How do you know that? Well, you just know it's not one of those 6 strong acids. Any other anion is going to be basic. So things like, the oxide ion, that's going to be quite basic. The sulfide ion, that's going to be quite basic. These are actually quite strongly basic. But everything else, so you've got phosphide ion and nitrite ion and the bicarbonate ion. So you name it. So it's normally a lot easier just to remember everything down here, right, from the strong acids and bases, and then you just recognize that all other cations are going to be acidic, all other anions are going to be basic. If they come from a strong acid or base, they're going to be neutral.